It's a great pleasure to introduce you to Uroš Nidic. He's from Serbia. He works at the Serbian Supercomputing Agency, and he also does consulting work out of a UK firm. Uroš will talk about Crossbow technology, which is a new technology which helps us virtualize networks. So I'm very excited to bring you Uroš. Thank you.
First I have to add that this Crossbow technology and my involvement in that was based as a contribution through OpenSolaris contribution website. It means that everyone can contribute code and do that. So basically my involvement included the contribution, so I wrote below OpenSolaris contributor because I contribute a little of code into the OpenSolaris Crossbow technology. And also we are now deploying this technology in our supercomputing center and in future, because we have some plans, of course, and it shows really good advantages among other stuffs. Well, first of all, I would like to tell you that my paper, which describes exactly how it works, what the rationale for Crossbow and everything, is on 253 page, and there is a almost complete explanation of everything. Now we will have to pass to 15 slides where I will show you what's going on in Crossbow, the rationale, why Crossbow established as a project, and what is advantages of this project. Well, let me start. I divided this presentation into 3 parts. First is Crossbow technical background. It means what's happened before Crossbow, how it worked before Crossbow. And then the you will see the rationale, why Crossbow, why there was a need for Crossbow technology. Also, I will tell you after the Crossbow, it has been introduced, the model of network machines and network in a box. It means that you could have everything in one computer, whole network with routers, with everything just logically interconnected. And I will show you that it is possible to do it with so small overhead that it is also measured in percents, 1, 2. First of all, Crossbow features. Crossbow features is something like advantages of Crossbow. The main advantage usually have in mind is this virtual NICs. It means you can just use one router and divide this router into smaller virtual NICs, virtual NIC network interface cards. You have one interface card and it pairs to the operating systems as a couple of network interfacing cards, which are virtual, and they have own virtual MAC addresses. We will see later that it could have some which you would like MAC address, or some random MAC address, and of course different IP address. So for example, for point of view of some developer, he could think that he owns a virtual NIC card, NIC network interface card, as a real network interface card. That is one of the results of Crossbow technology. Other results is something about quality of service. I think that it is really important because today market solutions which deal with quality of service are rather complex, and some of them are proprietary and expensive. In a Crossbow, quality of service becomes very simple. I mean, learning curve to learn how to deal with quality of service, which is really important today because internet is changing from to multimedia, to video, to everything, this quality of service, which you agree in two parts, becomes more important. And in Crossbow, it's so much easier to do than in existing software solutions. Of course, without any any payment for that. Also, you could sign service level agreements on a per connection basis. What basically it means? It means that you can have a hardware and a network, and your customer could come and want to agree with you some service level agreement, and you can arrange it without problem using the Crossbow technology, just typing, dedicating one virtual NIC to them, to your customer or customers, and adjust according to a specification you signed in a contract, which is quite good, I believe. Also, there is other stuffs, but I think the last one, better defense against denial of service, is also one of the advantages. For me, it's really important because from time to time, servers and basically any companies who is connected to internet from time to time experience denial of service during some attacks and everything. With the Crossbow technology, it is possible to deal with that really easily. And this is, let's say, important things. Also, it has, I wrote here other stuffs, and I say real-time usage in history. It means that you can track how your virtual NICs perform, how your Crossbow perform, without any penalties. It means that you don't have overhead. So you can have a log file and track later this log file transform some visual form to look nice. But basically, this usage, real-time usage, current usage, and history you can track without any penalties, which I think is really good. From my experience, I honestly don't know any, at least any free quality of service software who is offering such thing. There are some proprietary systems which have a lot of tougher learning curve. It means you have to learn a lot of, to read a lot of tutorials how to use them. But Crossbow technology is pretty much easier to use. I mean, so much easier to use. And there is also, if I will have time, I will explain you the background of the name, the Crossbow. Why Crossbow? Go to the next slide. This is how it works, basically. Basically in Solaris, now I'm only concentrated on Solaris, Open Solaris, it doesn't matter. And I just would like to tell you that some of commands, maybe if there are people who are coming from Linux world, are not the same. It means it exists in Solaris and do the same thing, but the output is slightly different. And I will mention this difference. This is what I wrote here, just in case that someone used Linux and know the command, but the command output is not the same. But let's start here. For example, for these virtual stacks, you can basically dedicate CPU power as much as you like, 1, 2, 3 random CPUs to your one virtual stack. Their stacks are realized by SQs. This is feature of, I'm not so familiar with Linux, but I believe this is the only feature of Solaris. They have implementation in some, I believe, in some versions of other Unix flavor systems and Linux, but in Solaris it's somewhat mature technology. And you can, for example, when you try to set up your container virtual, you're doing by virtual SQs. You dedicate CPU time you would like, and also you dedicate what you would like to do. For example, in your one virtual SQ, you say, I used some of these pictures to present it for simplicity. For example, you would like to have voice over IP, HTTPS, and some like default for all other traffic. And this you would like to use for one CPU, because your customer just bought one CPU power. And for example, for other resources, you can also make another virtual SQ where you put all other TCP and UDP traffic and virtual in default. All other traffic that doesn't belong to that goes to this default SQ. And this is something about SQs, which is a little bit older technology, but not conflicting with VirtualNICs. VirtualNICs come here when you want to translate these SQs to network interface cards to send them and to communicate by communication channel, whatever it means. VirtualNICs now come here in the middle part of this whole. This is something like middle level. They're just put it on that place. I will show you in the next slide how it's realized. And all other piece of code, piece of software downstairs doesn't actually behaves like it doesn't know about VirtualNICs. VirtualNICs is just something like piece of code which is precisely put it in a place that behaves like we would like to behave, but not touching other piece of system, other parts of code. So it means that there is that it interacts quite good with other technologies like SQ, like network interface cards, but we don't change anything except we introduce this layer. And I will show you in next picture about it. These VirtualNICs are only in control path only. The data link layer is bypassed. It means the data link layer has nothing to do with Crossbow. The data link layer even just doesn't care, doesn't see VirtualNICs. Data link layer is behaving as it behaves. You just do this job. Crossbow, VirtualNICs in this case, are a little bit higher in hierarchy in this OSI model, open software open system interface. And also, there is another thing about interrupts, because this is not only a problem we had to deal about VirtualNICs when we introduced this. There are a lot of interrupts which come here and all management, and this is another part of the story, which I divided these slides into two parts. For example, SQ switches MSI interrupts per stack between interrupt and polling mode and controls the rate of packet route for virtual stack. What does it mean actually? There is a polling procedure introduced in this Crossbow technology, which just, how to say, polls all VirtualNICs and see what kind of traffic is coming And according to that, and according to previously configured NICs, they do management quite well of those virtual NICs. And each of these interrupts, when it arrives in SQ, they switches to particular virtual NIC. So it means that this management polling, by polling, it basically manage virtual NICs and arrange in a queue how they will perform and how they will. If you, for example, one customer agreed with you service level agreement, which has quality of service, you would like that ping would be latency rate would be less than this one. This is done by polling mode. In polling mode, he takes care about these latencies, traffics, how much importance thing, stuff that. But also, Crossbow didn't change anything. I mean, SQ stays SQ, and MSI interrupts are staying MSI interrupts. They just through Crossbow technology interact with virtual NICs. I don't know if I'm clear about that.
When does it decide to switch from interrupt driven to polling?
When SQ receives MSI interrupt, after that it passed to, for our today presentation, let's say to Crossbow technology, and then Crossbow deals with that and manage according to configuration settings. So it's basically, for outside world, nothing is changed. But when it comes to Crossbow, then polling management system decides that.
And you tell it via configuration, or?
Yes, that is done by configuration settings. For example, which is just replication of service level agreement and quality of service, which these days becomes much more important.
Would it be fair to say that one would be more optimized towards latency and the other one towards
yes.
throughput?
Yes. For example, if you, it's up to your, for example, company to decide which options they could have. You can have. And for example, if one customer comes to you and say, look, I want to video streaming without latencies, without everything, and you can say, okay, we provide this option, and this is our service level agreement. We provide this QoS, quality of service, and according to that, system administrator, later I will show you the comments, 2 simple comments, but with lot of options. You just configure, and that's all. You don't have to take care about how Crossbow will deal with that, because they have this polling mode management, and interrupts, usual interrupts, they receive like SQ, just polling mode management takes care about that. This is something like observation of Crossbow architecture. Crossbow, as I showed before, partition all network interface cards, hardware, kernel queues, CPUs, and all these stuff. By using Crossbow technology, enable us to create these not only virtual NICs. I wrote here virtual NICs. I just checked here, but I didn't have time to polish this, my presentation. I'm sorry for that. But actually, the different machines, which we will see together in later slides, network in a box, whole virtual network in a box where we have virtual routers, virtual servers, everything in just one machine. Complete virtualization. And this polling is what I just explained in previous. This is just something like review. Dynamic polling on virtual NICs to schedule rate of package arrival per NIC. So we have some packets arrivals, and this polling management system inside the Crossbow technology, it belongs to Crossbow technology, makes decisions according to our configuration settings. This is a command called mpstat. I tried to see how mpstat behaves in Linux, and I saw that the output is similar, but not same. You have something like percents here with other things, but in Solaris is, for example, you could get this output. What is important for me is CSW, which it means context switching, and CSW, involuntary context switching. There are also other parameters, but when you have old driver, you could see the number of context switching, and when you have the Crossbow technology, you can see it's one order of size smaller. Also here, involuntary context switching is so much lower.